Hello. Hello, everyone.
Yep.
Okay, yeah. Hello, everyone. This is Enjia Mai. I'm a software engineer from Intel Zephyr team, and I'm so glad to have such an opportunity to introduce some of our safety-related work in this Zephyr Developer Summit. So my topic today is about conduct FMEA in the safety analysis of Zephyr. So in today's presentation, I would like to share following information with you. First, I will talk about what is FMEA and why we apply the FMEA in Zephyr project, and then I will show you how we do the software MEA, and also provide an example of the software MEA. Then we will have some conclusion in the QA. Okay, so please feel free to let me know if you have any questions during this presentation. Okay, so first, then we talk about what is FMEA. FMEA stands for failure mode and effect analysis. Okay, let me explain the terminology here. The failure modes means the ways or modes in which something might fail. Failure are any errors or defects, especially ones that affect the customer and can be potential or actual. And the effect analysis, it refers to study the consequences of this failure. So for the definitions, FMEA is a step-by-step approach for identifying all possible failure in a design or in a manufacturing or assembly process or a product or service. And let's take a look at this diagram. So if we have input, we have a process or design, and we can leverage the FMEA process, and then we will get the output. The output will be we will get a failure mode list, and we also get the effect analysis result, and we can identify some of the countermeasures for the failure mode. And actually, the FMEA is not a very brand new thing. It began in the 1940s by the US military. And if my memory serves, the latest official document, it's five edition FMEA handbook. It was published on 2019. Okay, so the characteristics of FMEA. So FMEA identify the potential failure modes in a system. It is a process of reviewing as many component assemblies and subsystems as possible to identify the potential failure mode in the system and their cause and the effects. And it estimates the risk of the potential failure. Failure will be prioritized according to how serious their consequences are, how frequently they occur, and how easily they can be detected. The purpose of the FMEA is to take action to eliminate or reduce failure. Start with the highest priority one. And the result of the analysis will be documented. For each component, the failure mode and their result effect on the rest of the system are recorded in a specific FMEA worksheet. And FMEA is often an qualitative analysis, and it is often the first step of a system reliability study. So it often as a first step of a system reliability study because it is an inductive reasoning, so-called for logic single point of failure analysis, and is a core test in the reliability engineering, safety engineering, and quality engineering. Okay, so and FMEA, you have several violations, and you might heard about the PFMEA. PFMEA means it is facing to the process. It is used for improving the process, and the DFMEA is facing to design. In our Zephyr project, we apply the software MEA. Software is one kind of the designed DFMEA. Okay, so why we apply the FMEA in our Zephyr project? The reason of conducting software MEA, the first reason here, as we have, is for the functional safety certification. IEC 61508. Functional safety certificate is important and necessary for Zephyr RTOS because our Zephyr RTOS will be widely used in safety, might be widely used in safety critical product development. Yeah, as you know, Zephyr will be used in different kinds of IoT device. Yeah, and they also might include some medical instrument. And for some medical instrument, it might be very safety critical. For example, you see this pulse meter. It might have some requirement for the safety, and for the another example is for the pacemaker. I think it is not good if the software of the pacemaker crash inside your heart, right? Okay, so another reason here is we can improve the quality of the Zephyr project. And during the FMEA process, we can get some advantages of applying it, such as we will check and review the design and the documents again and again, and we will try to find out the potential failure mode and the prevention. And the third reason is it is better adapting to develop a safety critical product for the application which once use Zephyr as its base OS. Okay, so how we do the software MEA? The generic method of implementing the software MEA, first, taking the interface between the hardware software or the software module as the analysis object, and then we enumerate the failure mode of the interface, analyze the impact of the failure mode on the software module or software requirement, especially the functional safety related part, inference. After clarifying the cause of the failure, control measures will be applied to the cause of the failure. And after, so the target of working product of the software MEA will be first one. The first one will be software in the software FMEA report, and we also generate some countermeasures that will be applied to our Zephyr code base, and we will also update some maybe some requirement document or other such as architecture document, something like that. Okay, so this is a flow of how to doing a FMEA for a single item. So first, the first step is we will walk through the software architecture. Then we identified the software, the possible software subcomponent. Then we described the software subcomponent functionalities. After that, we should select a applicable systematic software failure mode. The next step is we do the effect analysis, and then we will rate its effect, and after we get the rating of the infection, we will identify some countermeasures. Then we will rating the post mitigation failure again. See here, the light blue block means it is in an analysis process, and the green block means it's in a mitigate process. Okay, so let me show you a very simple example of how we applying the software MEA. Okay, so I'll take the schermophone, one of the schermophone component as the example to show you how to do failure mode and effect analysis. Okay, for step 1 and step 2, we should walk through the software architecture, and we will identify the related software component and the schermophone. So this is our Zephyr architecture diagram, and the schermophone is inside the kernel service. And we will also check the software architecture specification to see what the functionality described in this specification. Then, okay, let's look into more detail. And so I take this example. When you analyze the software architecture spec, we find some description, some functional description here, and it shows the kernel does not allow an ISR to take a schermophone. However, the ISR must not attempt to wait if the schermophone is unavailable. So this might be a potential failure mode here, and then we start our failure mode analysis, and For the step 3, we describe the software subcomponent functionality. Yes, as I just mentioned, we refer to the software architecture spec or design spec, then describe the functionalities. And its description will be the kernel does allow an ISR to take a semaphore. However, the ISR must not to attempt to wait if the semaphore is unavailable. For this functionality, we can refer the function k-semaphore take. Okay, so this is its functionality description. So for the next step, we will select applicable systematic software failure mode based on single functionality to analyze the potential failure mode of this functionality and decide its failure mode. So its failure mode could be delay, interrupt, request. If we call the semaphore take, we try to take a semaphore and we give in a delayed parameter. It means that the sleep will be happened, and we all know that it's not allowed to do sleep when you are in the program is in the interrupt context. So okay, so let's go to the step 5, effect analysis. So effect analysis is to analyze what effect will happen, include the dependency components while this failure mode might happen. This example is very simple, so I didn't talk too much about the dependency component, but actually in our practice, the dependencies also need to be considered. Okay, so the effect of failure in this example, it will be wrong data. If you use the delayed when you take the semaphore, it means that you might go into sleep and the interrupt might be delayed or missing in this case. So this is what its effect. And the cause of this failure actually is incorrect usage. So in this analysis, we also want to find out what the control detection will we have. So we can add an assert to check when it is in ISR. We cannot have a given the waiting time as a parameter. Okay, the step 6, we have to rate the effect. How to rate the effect? So in FMEA, rate effect is by the RPN number. RPN means the risk priority number. It shows the probability of the potential risk. So RPN is calculated by the severity plus occurrence plus detectability here. And you can see its severity is 7. And occurrence means how frequency it happen. Occurrences here we will rate it as 5, and the detectability we rate as 3. Yeah, it is easy. It's not so hard to detect. Okay, then we will identify the possible countermeasures for this case and design this countermeasures identification means we have to design the countermeasure which could solve or mitigate this risk. And then we try to decide is what the control prevention we can give. So we can we can make it technician phone operation cannot wait in ISR. So the countermeasures here, we added a Z macro to check, to catch the incorrect usage of technician phone. The incorrect usage means technician phone in an interrupt context with a delay. Okay, so after we identify our countermeasures, we have to rate its post mitigation failure again, and the post mitigation failure rate. You can see after we apply the countermeasures, the RPN number will be changed. Because we add a search to detect it, so the declarability is become the detectable. So we can rate it as 1. And this is the RPN number after we apply the mitigation. Okay, so you can see this table. Yeah. For the new software, if our software want to certificate the CO3, this means your RPM must lower in this number 80. And if you are an existing software, you have to lower than 16. Okay. So this is an example of our final software FMEA. You can see we show it in show this report in a Excel sheet format. Okay, and so conducting the okay, let's talk about the conclusion. My conclusion. Conduct FMEA is also to we can figure out some existing safety mechanisms in our Zephyr. For example, the user space. I believe Zephyr was born with some safety mechanisms. Because the user space you can have a temporal and spatial isolation. So I think, in my opinion, it's definitely a safety mechanism. And we also figure out the existing countermeasures in current code base. In Zephyr, there are already many countermeasures in the current code base, and we will address some potential failure mode that still need to be addressed. For example, some hardware interface doesn't have something like a feedback mechanism. For example, if I call, I try to operate, try to configure the MPU, but I don't know how the MPU is be programmed correctly or it worked. If it work or not. Okay. So another point is let's work together to make our Zephyr project better. It might have some impact and challenges for applying the FMEA. For example, we will have more workload on this, and maybe some rule needs to be changed after we apply it. But I think it is worthy to do that because it can make our Zephyr more safety. Okay, thanks for your listening. Let's my presentation today. Thanks.
Thank you very much. We have one question in the chat.
Yeah.
Where are the RPN threshold numbers for different SIL/ACM levels from 61508 or 2622?
Okay. Sebastian, sorry, I didn't mention it's what it originated from, and but actually I forget it. But I can find out list to you. Okay, I can find out it and send the email to you. If you are committed, you can leave your mail to me, and I will find out where it originated from. Okay.
Yeah, there was a question from Sebastian Schuler in the chat. And maybe someone else could read the question since I seem to be echoing.
Oh.
One from Cosmides Leonidas.
Okay. So, I'm so for the Leonardo's problem, I'm not very sure. I think yeah.
I think Leonidas, Amber is going to be having a BOF.
Yeah.
And so maybe that's a good question for her.
Yes. Okay, I will write down this question, and I'm sorry I didn't know how to also answer it because the safety activities I think it's belongs to the safety group, and I didn't know the rules or some contribution rules of the safety group. So I think Amber can help to ask these questions. Thanks so much.
Hey, Amber just joined. I'm
Hi.
not sure what the question is. Hi, everybody.
Hi, Amber. Wow, thank you for joining this meeting. And Leonardo asked a question. How can we contribute in the safety activities? Do we need to be part of the pre-team members organizations? I don't know how to answer this question. Could you help me?
Oh, that's the question? Yeah, and I'm going to rely on Kate to input here too. So I'll be going over this in the Birds of the Feather talk coming up, but the Zephyr project has a safety committee that's pretty active. That safety committee is a closed working group to platinum and silver members. So to be involved in those discussions and contribute there, you need to be a platinum or silver member. Though, you know, a lot of the safety activities that we do, a lot of the work is on our code base, right? And so anybody theoretically from the community can contribute on some of the activities. An example of this would be our coding guideline compliance work. So our coding guidelines are published publicly, and anybody can contribute to those. It would be welcome. So there are examples of things that feed into safety that anyone in the community can contribute on, but to be part of that closed working group, you need to be a member. Does that answer the question?
Yes, it does. At least from my nice job.
Good.
Oh, nice job. Yeah. Okay. So I think we're sort of at the half, like I say, I think we're at the half-hour mark now. So again, thank you very much, Enjia, for a very good presentation. Much appreciated. And there's some thank yous sitting in the chat as well for you to look at. And then, so I think Roberto, if you want to stop screen sharing, Enjia, we'll let Roberto have his session now.
You.
Thank you. Thank you for staying up so late.
Thank you, Amber.
Thanks, Enjia.
Okay, can you hear me?
We can indeed. Are you comfortable being recorded and keeping the recording going?
Okay, yes, sure.
Okay, then that's fine. I just wanted to check. Thank you.
Okay, so let's start. I will speak about the status of Zephyr with respect to MISRA compliance. Before I can do this, I need to introduce what is MISRA and what is MISRA compliance, because it is quite frequent that there are misunderstandings in this field. So here is a plan of the talk. I will first say a few things about the C language, and then I will introduce MISRA and MISRA compliance, paying attention to what might be the misconceptions that are more frequent, and because I know them, having participated in several open source projects. And then I will talk about the status of compliance of Zephyr with respect to the MISRA C guidelines from a very broad point of view. Okay, so first a disclaimer. I am a member of the MISRA C working group, and I also represent Italy in WG14, which is the C standardization working group. However, these groups only act officially with documents, so whatever I say does not necessarily represent the position of MISRA C working group, or of WG14, or let alone ISO. Okay, so the question, the rhetorical question I start with usually is, do you want to reason in assembly or do you want to reason in C? And of course, the answer, I guess, would be, as much as it is feasible, I would like to reason, to program in C and to reason about my programs in C. So if the reason is that C has several very important advantages that from an economical point of view are compelling since almost 50 years. So C compilers exist for almost any processor, and the compiled code can be very efficient without hidden costs. Without hidden cost means that, setting aside the peculiarities of multi-core architecture, an experienced programmer can more or less guess from the code what might be the cost roughly. C allows writing compact code. There are many built-in operators, and you can write quite complex things by writing a limited number of lines of code. It is defined by an ISO standard, and possibly with extensions allows easy access to the hardware, which is essential when you develop operating systems or embedded systems in general. And C has a long history of usage, especially, in all fields, including in critical systems. And C is widely supported by tools. So these are all advantages of C, and these are such that even today, C is the most used language overall, and in particular for the development of embedded systems. However, C has always been faithful to its original spirit that we can resume in this semi-serious commandments. So trust the programmer, let the programmer do anything, and speed is more important than portability, and so on. And many of these features of the language are bad for safety and security, from the safety and from the security point of view. What is the main source of this problem is it comes from the notion of behavior. And in the C standard, here I am quoting C99, but it's basically the same in all versions of the standards. Behavior is something that is observable from outside the program, so something that is externally visible. And as a result of this definition, the compiler uses the as-if rule as much as possible. By this rule, the compiler can do any transformation that ensures that the behavior that is observable from outside the program is as specified by the standard. And this is not just true in C. It is true also in C++, in all languages that admit an optimized compilation implementation. In the as-if rule, we have the majority of the opportunities for the compiler to generate optimized code. So due to this, there are behaviors in C that are not completely defined. So we there are several varieties of not completely defined behavior. We start from the most dangerous one, which is called undefined behavior. This is behavior whereby if you use non-portable constructs or data or something similar, the standard does not impose any requirement, meaning absolutely no requirement. So the application that engages in undefined behavior may crash, may do just anything, including formatting the hard disk. This is what is often said to people that don't get it. And the reason this happens is that the compiler has the freedom, the complete freedom to assume that undefined behavior does not happen. It is the responsibility of the programmer to ensure that undefined behavior does not happen. If it does happen, it is the programmer that has violated the contract, and consequently, there is absolutely no warranty on what may happen. Here is an example of undefined behavior. It's undefined behavior whenever the program attempts to modify a string literal. Here we have a simple example. The programmer wanted to basically neutralize the last two exclamation marks. And so the programmer writes a string terminator in position 6 of the string literal, and this is undefined behavior. It doesn't. Anything can happen. And basically, one reason anything can happen is that the string literals may be in read-only memory. And if you try to write to read-only memory, what may happen is unpredictable from the point of view of the C language. So there may be some hardware exception, and what are the consequences of this hardware exception? The C standard cannot know. So we will see another reason why this is undefined behavior. Another variety of non-completely defined behavior is called unspecified behavior. This is when there are two or more possibilities to implement one thing, and the standard says that it will be one of those without specifying which one it will be. And there is no requirement imposed besides this. In particular, the compiler needs not document the choice, and it needs not be consistent with the choice. So let us consider an example. It is unspecified behavior, for example, in an addition, whether the left-hand side operand is evaluated before or after the right-hand side operand. So it's unspecified. So this program may print "hello world!" exclamation mark, which is probably what the programmer intended, but it can also print word exclamation mark hello blank, which is probably not what the programmer intended. And as I said, the compiler needs not document the choice, and most importantly, the compiler needs not be consistent with this choice. So you may discover that the program does what you want when you don't use any compilation option, then you activate a certain optimization and you see that it is the other way around. And moreover, if you complicate the program a little bit, instead of returning immediately in main, you do 5 times this addition, you may find that the compiler is not consistent in these instances, and it has complete right to do so. And then there is implementation defined behavior, a third variety of not completely defined behavior. And it is like unspecified behavior, but this time the implementation must document how the choice is made, and it must be consistent with this documentation, of course. Everybody knows that there are C implementation where int is 32 bits or it's 16 bits. This is one of the many implementation defined behavior. There are more than 100 in the C standard, which means that the theoretical number of C dialects is basically very, very large, infinite to any practical effect. So why is C not fully defined? So there is undefined behavior, unspecified behavior, implementation, defined behavior, and we skipped the local specific behavior because it is less interesting for the topic of this mini conference, which is safety. So why is the standardized language not fully defined? And the reason is basically that implementing compilers is easier this way. Not just that, it is easier to implement compilers that can generate fast code. This is the reason why the language is defined this way. So let us see the same example we have seen before. So it's undefined behavior if the program attempts to modify a string literal. We have seen one of the reasons. The string literals may reside in read-only memory, but there is another reason. So the C compiler, thanks to this, is allowed to merge string literals. So if you have the same string literal several times in the program, there is no obligation for the compiler to have a separate memory representation for each of those. To the contrary, most compilers do use a unique representation for each string literal. But even if there are different string literals, and here I have an example. So I have the literal tail and head tail in the same program, and the compiler can only store head tail and use a pointer to the fifth character when a representation for the string tail is needed. So it's undefined behavior also because changing one string literal may change other string literals. And the compiler can assume this will never happen. So you see that with this combination of two reasons, we have basically, if the string literal is in read-only memory, you cannot write it because if you try to do so, something unknown will happen. If the string literals are not in read-only memory and you succeed from the, say, hardware point of view in writing them, then you may change other literals without you realizing this. Another example is very instructive, is another undefined behavior that has to do with shift operators. So it's undefined behavior when an expression is shifted by a negative number or by an amount greater than or equal to the width of the promoted expression. So it's rather easy to understand why a negative shift count is undefined behavior. If the language was not defined this way, the compiler would be forced to say for every shift test the shift count for negativity and then do something sensible. For example, shifting to the left by -2 position might be compiled as shifting to the right by 2 position. So this is easy to understand. What is less easy to understand is why should it be undefined behavior shifting a 32-bit quantity 32 bits to the left. So one might say, well, if I'm pushing 32 or more zeros from the right-hand side, the result would be 0, no? And the answer is no, because on very popular architectures, such as the Intel main architecture, the first thing that happens to the shift count is that it is masked. Only the low order 5 bits are retained, meaning that for example, shifting by 32 positions is the same as shifting by 32 position masked, which is the same as shifting by 0, which does nothing. Okay, so you believed that the result would be 0, whereas in reality, on this architecture, shifting by 32 is a no operation. And again, C leaves this behavior undefined for speed and ease of implementation, because this is the philosophy of the language. The philosophy of the language is that whenever this is possible, a high-level construct should be mapped to one machine instruction or two machine instructions or the least number possible of machine instructions. Okay. So MISRA is a subset of the C programming language. So it has a quite long history. It started in the 1990s. Ford and Rover were developing their in-house coding guidelines for programming automotive software in C, and they joined forces under the umbrella of the MISRA project. And so this is how the first version of MISRA C, dated 1998, was born, and this was revised in 2004 and 2012, and it is still being revised. So we have now MISRA C 2012 Amendment 2 that has extended the applicability to C11 and C18, and the MISRA C working group is continuously active in extending and improving the coding standard. So the point to be understood is this, that the strong point of C each come with a weak point. So, and they are not easy, they cannot be separated from one another. So, for example, the fact that is, as I said, it is relatively easy to write efficient compilers for almost any architecture is one of the main reasons behind non-definite behavior. So the high-level constructs are mapped to machine language instructions, and since there is a variability between the semantics of machine language instructions, this is one of the main causes of non-definite behavior. The fact that you can write efficient code with no hidden costs is also because there is no runtime error checking whatsoever. The fact that there are many compilers and yet the language is defined by an ISO standard is another reason why there is non-definite behavior. When two or more compilers disagree on some aspect, the only way forward in the standardization committee might be to say that something is not defined or not completely defined or defined by the implementation. The fact that it is easy to access the hardware in C is the same reason why it is so easy to corrupt the program state, for example, overwriting the stack. And the fact that you can write compact code is the same reason why it's so easy to abuse the language by writing something that is not comprehensible. Okay, so given this, the solution found by industry is called language subsetting. Language subsetting means we do not program critical applications, especially safety critical application in C. We write them in a subset of C, okay, in a subset such that the likeliness of introducing potentially very dangerous mistakes is reduced. In some cases, it is eliminated. Okay, and the most authoritative language subset for the C programming language is MISRA C, and this is why we are talking about it today. So let me say something about the guidelines. Of course, in half an hour, there is no way I can present even a single guideline. However, there are 175 guidelines. This is the number of guidelines in MISRA C 2012 revision 1 with amendment 2, so the very latest version of the standard. And each guideline is classified as either a rule, these are the majority, or a directive. When a guideline is called a rule, the information concerning the fact that the code is or is not compliant is fully contained in the source code and in the implementation defined aspect of the tool chain. So modulo the important limitation of undecidability of several program properties, when it is a rule, a static analysis tool or can be expected to say something about compliance without any help from the user. When it is a directive instead, then the information in the code and in the implementation defined aspect of the tool chain are not sufficient. Requirements have to be taken into account, specification, in some cases also the programming intention has to be taken into account. So for directives, static analysis tools may help considerably, but they need some more information that that is provided to them. Okay, a very important distinction has to do with the category of the guidelines. So there are 3 categories defined by MISRA. So the category mandatory is for guidelines that do not admit any deviation. So if you violate any mandatory guidelines, then the code cannot be, the project, sorry, cannot be MISRA compliant. It will be non-compliant. There is no exceptions. There are no exceptions to this. Whereas for the category required, you actually have a choice. You may comply to the guideline, or you may raise a formal deviation, meaning that you have to write an argumentation where you describe why the rule is being deviated, and why, despite this, the code is safe, meaning that the problems that the guideline is meant to mitigate are dealt with in another way. And then there are advisory guidelines that are recommendations. So they should be followed as far as it is reasonable to do so. Formal deviation is not required if you decide to violate them in some cases, or even in many cases. But non-compliances should be documented. So in the end, unless you disapply them, and this is something I cannot go, disapplication of a guideline is an expression I will use later, but say, so only advisory guidelines can be disapplied. And to disapply them, following the MISRA Compliance 2020, which is a document I will mention in a second, you need to give an argument why you are disapplying the guideline. One thing that is very important to understand is that MISRA C is prevention. It's not bug finding. So MISRA C is part of a documented software development process. Okay, so and it has very little in common with bug finding. And in fact, the deviation process is an essential part of MISRA C. The MISRA documents themselves, they do not recommend to blindly comply with the guidelines unless they are mandatory. They always require to make a balance between the pros and cons of complying or deviating. And in fact, the point of the guideline is almost never, you should not do that. So it's like this only for mandatory guidelines that are a tiny minority of all the guidelines. The point of the MISRA guideline is, look, this is dangerous. You may do this only if it is needed, if it is safe, and if you can explain to your peers in 30 seconds that it is both needed and safe. If it takes 20 minutes of reasoning on the code, following with your fingers, trying to understand whether it is safe or not, this is not good. Okay, it should be obvious that it is needed and safe. This is the spirit. Okay, one of the most useful way of thinking about MISRA C is to consider this compliance as a way of conducting a guided peer review. So in an ordinary peer review, you would sit with your colleagues pointing fingers at the screen, and everyone would raise concerns about things they see in the code. Whereas with MISRA C and the good tool, the tool is guiding you. So the tool is guiding, is telling you, hey, here you have an implicit conversion that is not guaranteed to be safe. Are you aware of this or not? Okay, for example. And in fact, another aspect that differentiates the MISRA C attitude from the bug finding attitude is the importance that MISRA C assigns to reviews. So code reviews, reviews of the code against design document, reviews of the design documents against requirement. And in fact, many MISRA rules and guidelines have to do with code readability and understandability. Okay, now MISRA compliance. MISRA compliance is not something that, well, it's something that is regulated, and the document that describes in quite precise terms what are the conditions upon which you can declare that the project is MISRA compliant is MISRA Compliance 2020. It is a new version of the document MISRA Compliance 2016, and this is applicable to all the version and revisions of MISRA C and to MISRA C 2008 and MISRA C++ 2008. For the time being, the adoption is optional, but it will become mandatory starting from the next editions of MISRA C and MISRA C++, because the chapters having to do with compliance that are now contained in both MISRA C and MISRA C++ have been factored out and extended, and they will be removed from MISRA C and MISRA C++ at the next editions. There are concrete advantages in adopting MISRA Compliance 2020 now, and in particular, one of the advantages is that you can disapply advisory guidelines, and this is something that is an advantage. There are other advantages in adopting MISRA Compliance 2020 today, even if it is only optional, the adoption. Now, one thing to be understood is that yes, there is a possibility of deviating from guidelines, but this is regulated by MISRA Compliance 2020. And here I am quoting basically literally from the MISRA Compliance 2020. In particular, what has to be understood is that deviation must not be permitted simply to satisfy the convenience of the developer, or the developer says, I don't like the rule, or I disagree. And so the point is that the deviations have to follow, in order to be permissible, they have to take into account several factors. Now, I am a little bit out of time, so I will not go through these points, but the next slide, this slide, is another excerpt from MISRA Compliance 2020. It says that a proposed deviation should only be approved if it can be justified on the basis of one or more of the following: code quality, access to hardware, adopted code integration, non-compliant adopted code. So let me use this just to stress again that code quality comes first. So whenever you have a required rule and you believe that complying with the guideline would decrease the quality of the code, this is a good argument to deviate instead of complying. So code quality comes first and safety comes first, okay, more than any other thing. Now, let me say a few words about the status of compliance of Zephyr with respect to the MISRA C. I should have added a couple of slides of disclaimer, including the fact that I'm not very familiar with the Zephyr project. I didn't study any documents about the project and so on. What we did was to analyze a build of the Hello World sample project for the app-squared board using the SDK 0.12.4. I think this is not the last one, the latest one. I think now we are at 0.13 something, but I don't think this changes very much. And we have taken the subset of the MISRA C 2012 guidelines that are indicated in the coding guidelines section of the website where documents about Zephyr are kept. So 145 are selected out of 175. So in fact, there are 30 guidelines that are disapplied, so that are not applied. Now, with this, for this build, we identified around 32,000 violations. And this concerned around half of the selected guidelines. I think there are violations, if I remember correctly, for 77 guidelines out of 145. And we have around 20,000 violations for required guidelines and 12,000 for advisory guidelines. So, as I said, advisory guidelines are recommendations, so I wouldn't consider this 12K problematic, whereas 20K is something that requires attention. Okay, so what are the most violated rule? I call them in the slide the usual suspects, so implicit conversions. So basically the series 10 of MISRA C 2012 accounts for more than half of the violations of the required guidelines, and these rules have all to do with basically implicit conversions and the risks associated to implicit conversion. But also, I have looked at several of them. So the point is not just the guideline. So in several cases, when you want to study a piece of code, the fact that there are implicit conversions playing is something that makes the code less readable. So you have to pay a lot of attention to make sure that the implicit conversion is safe, is what it does what you expect it to do. However, I have also taken a look to the 30 rules that are in fact disapplied, and 17 of them are advisory. So okay, good. It's I mean, applying MISRA Compliance 2020, they can formally be disapplied. You need to write an argument why you disapply them, and this is not very challenging in many cases. However, 11 of these 30 disapplied rules are required, so they cannot be disapplied. Okay, so they can be deviated, but not disapplied. So this, I think that if MISRA compliance is one of the objectives of the Zephyr project, this selection of coding guidelines has to be reconsidered, and especially because there are even 2 guidelines that are mandatory in the set of rules that are disapplied. I think that in some cases this is an oversight. So, for example, Rule 20.6 is a rule that has to do with using the preprocessor in a way that is, I think, completely useless and is undefined behavior. So I think that this was excluded by mistake. I didn't have time to check whether the Zephyr project does violate this rule. I don't even believe it is violated. So because required and mandatory rules cannot be disapplied, I think that this list has to be reconsidered. So I think that I am out of time, and so let me conclude. The advantages of C have corresponding disadvantages, and so for when you write a code that is meant to be safe and or secure, language subsetting is a crucial activity. Of course, this will not ensure that the code is bug-free, but that if the code is MISRA compliant, you can program in C almost as if you were programming in Pascal. Okay, so which means that, for example, if you will do the right thing concerning a non-definite behavior, meaning that at least the software will have a definite semantics. And MISRA C is the most authoritative subset of the C programming language for the development of high-integrity systems. And what is important to be understood is that MISRA C is an integral part of a software development process, and the adoption is completely different from bug finding. So I'm insisting very much of this because quite often, especially in open source context, the counter argument is, hey, I'm violating the rule, but it's not a bug. That is not the point. Okay, the point is not that it is a bug or not. The point is what I've said before. Is it needed? Is it safe? Is it easy to explain to your colleague or to yourself 6 months from now that this both needed and safe? This is the point. Zephyr is definitely not in bad shape. I consider it among the projects that I have seen, the similar project. I mean, now I don't know. As I said, we analyzed Hello World in just one board configuration, so I don't know which part of the code base did we analyze. Maybe it's just a small part, but there are similar projects that are starting with millions of violations. So it's such a number of violations that the concern whether it will ever be possible to have a statement of MISRA compliance or MISRA readiness for this project is questionable. Whereas Zephyr is, I think it's doable. So it requires a coordinated effort, and but I think it's perfectly doable, and I think that the project overall is in very good shape from this point of view. Okay, so if you have questions.
Thank you very much. I'm not seeing any questions. Please raise your hand if you want to ask some questions, or else unmute your mic and start talking and asking. Oh. I think we're getting, no, we're not seeing anything showing up here. So thank you again.
I don't know, is anybody looking at the chat? I'm
looking through the chat and I'm not seeing any open questions right now.
Okay, but, thanks.
Thank you very much. That was really useful information, and it's nice to know that it's possible for us. Appreciate that. I do have one question. I was just wondering, can you sort of say which other projects you were looking at in open source, so just so we have some baselines at all, or are you uncomfortable doing that?
Yeah, well, I have looked at Linux and at ARM Embed OS, and Linux next, and also ARM Embed OS have millions of MISRA violations. So yeah, they are, yeah.
Thank you for giving us that context. It helps. Appreciate it. Okay, and then I guess with that, then I'll say thank you very much, and we'll move on to Amber having a birds of a feather session for us.
Great, thank you, Kate. I don't know if this would be helpful, but I think, you know, maybe one thing to clarify with your work, Roberto, is that you are doing the scans on a specific build, right, or builds to come up with your number of violations. And, you know, I just want to be clear that I just want to differentiate for our safety certification. You know, it's going to be a very specific build, and we're going for compliance on our auditable branch, which will be based off of LTS2, and it's for a limited scope of our code base. And so at least in the first phase of what we're doing for safety certification, you know, there is a delta between what you're presenting and what the case is for our safety certification, if that makes sense. I just thought I'd add that clarification for the audience. Okay, all right, let's move on. Let me share my content. Okay, can you see my screen? Yes? No?
Yes.
Okay, cool,
Yeah,
thank you. Was that Enjia?
Just one question, Amber, before you get into it. Are you comfortable with the recording turning on? Or let me turn it on?
That is totally fine, yeah. And I'll turn my camera on so you guys can put a face to this. Okay, so welcome to the Birds of a Feather part of the Safety Mini-Conference. So really the goal here is to just give you all a very high overview of what we're doing with safety and then open it up for questions that you might have. So I'm Amber Hibbard, I work at Intel, and I'm the Zephyr project safety architect. All right. Okay, so like I just said, the objective is just to give that high-level overview of the project plans for safety and where we are currently at. I assume most of the audience is familiar with functional safety, safety certification, and all of that stuff. Oh, Flavio, that question's not for me. Is that a question for me, Flavio? No. Okay.
Oh, I'm trying to answer these questions
Oh, okay,
that
thank
are
you.
coming
Okay, I'm
in
gonna
chat.
close
Yeah,
the
if
chat
I need
so
help
get
from you, I
distracted.
can, or
Okay.
they can always direct to you, but I'm trying to answer some of the questions.
Perfect. Thanks, Flavio. So for those of you that might be completely new to safety, just super high level. So safety is about minimizing or mitigating systematic fault in your code base. And why would you want to do this? Because the idea is that in the end, it will provide you a high integrity, robust, low fault code base that can be used in safety critical applications. You know, and there's a wide range of safety critical applications. We can think about robotics, we can think about self-driving cars, and we can think about lots of applications in the medical field. Okay, so the Zephyr project. We've been gaining a lot of momentum recently with regard to safety and our safety activities. We established a safety committee in 2019, so it's been going for around 2 years. That safety committee has a number of platinum and silver members. To name a few, we have Intel, of course, we have Parasoft, Synopsys, Google, Linaro, etc. So all of these participants, you know, some of them bring a lot of expertise in safety, and some just bring interest in safety and helping the Zephyr project work towards our safety goals. Everything that the safety committee does, especially things that really impact process or how we interact with community, we bring all of our updates and decisions to the Zephyr project technical steering committee. So we've decided so far that we're going to work towards the IEC 61508 standard, towards safety integrity level 3. So to reach a systematic capability of 3 for our auditable code base. As you are probably aware, we are a pre-existing code base, so we're going to be following Route 3S in the standard. We currently have a number of safety activities in progress. So Roberto just gave a nice overview about MISRA compliance. So we do have a published coding guideline, and we are in the beginning of working towards compliance to that coding guideline. We are putting in the pieces for traceability requirements, test coverage, tooling, and a lot of things that are necessary to meet the IEC safety requirements. And we'll go into a little more detail in the following slides. We are starting engagement with experts and authorities in safety. So we just hired a functional safety manager. She has come on board this month. She used to work at one of the certification authorities. TÜV-SÜD is an expert in safety and brings some great knowledge with her to help direct our activities. And then we're hoping by the end of this year to also, or early next year, to start our engagement with a certification company. We've already had initial discussions with TÜV-SÜD and TÜV-SAR, so those are 2 possibilities. Okay, so for our certification to IEC 61508, SIL 3, we've decided on our tentative initial scope. The idea here in part was to be very targeted and to choose a very limited but relevant scope. And so this is primarily the kernel. So the in-scope parts for certification are shown in blue in this diagram. We are considering doing the certification in the context of two architectures, which would be x86 and ARM. This is our initial scope, and so there is possibility to expand this in future certification iterations. Yeah. Okay, so high-level roadmap of where we're at. So as most of you probably know, Zephyr just released our version 2.6 just a week or so ago. And so we're currently starting work on 2.7, which will be our LTS2, so our second long-term support release. So in the last version, like I've mentioned, we agreed upon and ratified our Zephyr project coding guidelines. Some activities that we're working on, that we worked on in 2.6 and that we're continuing into 2.7 are putting the tooling in place for traceability. So for quality software development and also a requirement per the safety standards, you need to demonstrate full traceability from requirements to test cases. And so there's a number of different puzzle pieces here that we're fitting all together. And so that includes having a set of functional requirements that define our scope for certification and having test cases that cover all of those requirements. This also requires a number of software tools like a requirements database. And for all of these tools, it's important to note that we are doing it to keep open source software development in mind. And so we are trying to, as much as we can, choose software tools that are open source. So some other things, I mentioned the certification authority engagement, which we hope to have established by around end of this year. We're putting in the CI infrastructure for our coding guideline compliance. So it's not fully integrated into CI yet. Parasoft is a member of the project and a member of the safety committee, so we will be using their scanning tool for this. We've started work on all of our tools evaluation, so all of the software tools used in our development need to be classified, and then some of those will need to have some qualification or validation work done. And so we're starting the initial steps there to get the tools work done. So by the time we reach LTS2, which is fall of this year, we plan to, when it makes sense, to branch off and have that branch on our limited scope be our auditable code base. And this is the branch where we will achieve 100% coding guideline compliance, 100% test case coverage, etc. And then, of course, there's a whole lot of other safety collateral that comes with safety certification. Some of that's noted here. We have a tentative list here, and this is not meant to be read through each thing. It's just to show that we are being thoughtful of what's coming, what's anticipated for all of the artifacts we'll have to submit for certification. This is, of course, pending the actual engagement with the certification company and what we agree upon and what they think is necessary for Zephyr certification. But what I want to highlight here is that a lot of these artifacts for certification will only be available to Platinum members. Of course, some of the stuff as an open source project is going to be public, like the code base, the coding guideline is public. Some of our test plans, development plans, and again, this is tentative, we intend to make all of those public, but, for some of the really central things to safety, like safety analysis, for instance, FMEA, like Enjia talked about, those sorts of things will be reserved for Platinum members. And I think that's it. So what questions do you have?
Thanks, Amber.
Of course.
Looks like I've got the echo again. For requirements, how can people help participate in that? How is that going to be structured? I'll start us off while others are waiting.
That's a great question. So, so for pre-existing software, you have to think about, so if you guys are, and I'll just put this up here. So you can think about, can you guys see this okay if I don't put it in presentation mode? Can you see this V model? Yes, no? Okay, I'll take that as a yes.
Not really. Not really.
What's that? Oh, not
Bigger
really,
is
okay.
better.
Thank you. Okay, I'll just present this. So a lot of you are probably familiar with the V model, right? So the V model kind of shows a normal or compliant software development process where you really begin with requirements, and then you write architecture design specs, module specs, etc. And then eventually you get to your code. And at each step of this, there is some sort of verification or validation that's required. This works really well if you are doing compliant software development, meaning that from the beginning you're developing your code base with safety in mind. For us, since we have a pre-existing code base, what we have to do is sort of reverse engineer a lot of this. And so we have our certification scope, but we don't have a set of requirements that go along with that. And so we're looking at that scope, we're looking at the code base, and we have to now come up with a set of functional requirements, and if necessary, per the certification authority, higher level requirements like market requirements, but those are easy. And so we're really just in the beginning of doing that. And before we start to document those requirements, we want to put in place all of the tooling for it. And so we're looking at this requirements database tool called Doorstop, which is an open source tool. So we think we're going to use Doorstop for our requirements management. And then we've come up with a really nice flow, which helps us with our traceability. So our requirements to test case traceability that uses basically Sphinx and Doxgen, also open source tools, to provide all those linkages. And so to get back to your initial question, Kate, I would say that it's probably going to be about 4 months out where we're in a place where we have the tooling infrastructure in place, and we have nice guidelines for requirements contribution that the community could go off of to help add that content if they're interested. And so at first we'll just focus on the kernel, on our certification scope, write out those functional requirements, but then going forward, there's a possibility that the Zephyr project will think about when any new code is added, also making sure that there's a corresponding functional requirement to go along with that. Does that answer the question?
That answers the question, and that's kind of what I was hoping we were sort of heading towards, such that when this new RFC, eventually there'll be a requirement that's comes along with it right from the start.
Yeah, I mean, exactly. That would be the goal. And of course, this is something it's something in the safety committee in the next month or so, we hope to agree upon the process, and then we'll take it to the technical steering committee and make sure that the whole TSC agrees upon the process that we want to put in place for establishing requirements.
That sounds good. In terms of the technical steering committee and the coding guidelines from the MISRA, how do you see the community getting engaged there in helping us move it forward? Roberto is saying we need to get organized, so how are we going to do it? Any thoughts there?
Yeah, that's another great question. And it's a little similar to the answer for requirements in that, so the last couple of safety committee meetings, coding guideline compliance work was the main topic of discussion. And so, we are working with Roberto, and then also, of course, Parasoft, that's a project member, to really figure out not only a strategy for how we should start approaching our coding guideline compliance, but also figuring out resources and that sort of thing. And so I would say, again, within like the next few months, we should really have a well laid out plan for how we want to approach coding guideline compliance. And that will all be made public. So if the community is interested in helping, that will definitely be possible.
So like, is the thinking to, find 1 or 2 rules, focus on them, and then sort of, try to get the code base clean for those, and then just keep adding rules? Or are we going to have a master set? I know it's early days, but I'm just curious where
Yeah.
your head's at.
Right. Yeah. What we're thinking is to, right. So we have like 145, 150 approximately rules right now, and that's a little unwieldy. And so we're thinking about doing it in chunks and starting out with a smaller set first and then building from there. But again, that's still in discussions. It is the topic of the next safety committee meeting. So we hope to make a decision there soon because we really need to move our compliance forward. You know, right now we do have compliance activity happening in the project. It's mainly by developers that are, you know, project members who are using Parasoft to, you know, do their scans and then just kind of in a little bit of an ad hoc way right now, address certain rules and address those violations. But we'd like something a lot more organized and managed. And we are hoping to make decisions around that soon.
Cool. Thanks, Amber. Does anyone else have any questions? Feel free to either raise your hands or type in the chat or unmic. Not seeing anything, so I guess then if we don't have any questions, I'll say thank you very much, Amber, for stepping in and giving us this overview. It is very much appreciated.
Of course, yeah, my pleasure.
With that, we'll probably just end the session then and let everyone have some time back to go and be effective. Thanks again.
Cool, thank you, Kate. Thanks, everybody.
Yeah. And thanks to all the speakers.
Great presentation.
Very much. Thank you, Roberto. Thank you, Enjia. Much appreciate you guys coming and sharing your information with us.
Thank you. Bye-bye.
Thank you. Thank
Bye.
you so much.
Bye-bye.
Bye-bye.
Thanks.